Okay, good morning for friends in Asia, and also good evening for our fellow friends in Canada. Welcome to RoboCup at Home online classroom, and today we have this special invited lecture series that we have invited a very nice guest from Canada, UBC Open Robotics from the University of British Columbia. Today the topic is taking up a challenge as an engineer, and I will do more introduction after this. So let me turn on the slides. Okay, so this is the arrangement for today. So I hope we have friends from all over the world to join. And just a friendly reminder that the whole session will be recorded, so just be careful on your privacy. So just turn off your mic, so if let's say like you are not presenting, and if you have anything that you would like to share and you are not the presenter, please kindly drop your message in the chat session. So I hope like you can turn on your chat windows and you can put down whatever message over there. So if let's say like you cannot access the chat, please contact me. So you can I think like I should be universal to all the participants, so you can actually send me a chat or send me a message, then I will try to add you into the session. Okay, so I hope like everyone can get used to this new platform that we have just switched from Zoom. Okay, so today we have invited this special guest, and I will introduce them in more detail after this by showing the biography. First, I would like to introduce myself. So I'm Jeffrey from RoboCup at Home Education, and I'll be your host for today. Okay, first, just allow me about 2 minutes to introduce you what is RoboCup at Home Education. So RoboCup at Home Education is an education initiative in RoboCup at Home that promotes educational effort to boost RoboCup at Home participation and artificial intelligence focused service robot development. And currently under this initiative, we have 4 efforts that is in active operation. So the first thing is we organize education challenge, and this education challenge take place in national level, which is in various our member country, and also regional, for example Asia Pacific, European, and America, and so on. And also we have international, which is this year is supposed to take place in France, RoboCup 2020, but somehow it got delayed to next year. So we will have our education next year in RoboCup 2021 in France. Okay, right, so that is the education challenge that particularly for new beginner teams to join at home competition. Right, then the second effort is we focus on open source educational robot platform development. We actually promote a lot of our members teams to join in together so that we can develop open source technology, and also software packages, and also hardware design. We try to create a platform so that we can gather all these resources together to share among our member, and also to offer to the public. Okay, then not just gathering all the resources, the third effort that currently we are putting a lot of effort is we try to transform all these resources into teaching material and learning materials. Okay, so we have our online courseware that we put up on our website. So it's focused on the learning of AI focused service robot development, but you can say it is actually learning AI and also service robot development. Okay, and robotics development. So we talk about a lot about vision, we talk a lot about speech, and also navigations, and so on. So we transform all these things into videos, into PowerPoint slide, into notes, and into like we even open source a lot of the development, become the repository and also software packages in our GitHub account. Right, so you can find all the videos and all these materials on our website, and a lot of our and we share in a lot of this open public repository. And lastly is this outreach program. So we would like to push all these things. how to learn about AI, how to learn about service robot development. We would like to push all the resources that we have gathered to all around the world, regardless your background, regardless your color, regardless your age. So we actually try to promote even as young as school children to actually learn all these things. So that's why in our activities we have open category and also junior category. So we would like to promote younger generation, even as young as, like, if you watch our previous invited lecture series, we actually have high school students that actually they talk about YOLO, they talk about OpenVINO, and also all those deep learning framework and also algorithm in their development. So it is a very nice result that I can say that our activity actually promote a lot of all these things to everyone around the world. Okay, so for more information, please head to our website, and also if you would like to interact more with us, please join our Facebook group. Okay, so we have a Facebook page, and to spread all the news, and also if you would like to interact with us, feel free to join the group, our group, which is you can find the link to our group in our Facebook page. Okay, and lastly, I would like to thank all our sponsors throughout all this year. So RoboCup, and so MathsWorks, SoftBank Robotics, Jupiter Robots, and also IEEE Robotics and Automation Society, right? So they have been provide us a lot of support in terms of financial, and also in terms of event support, and also technical support, etc. Okay, so without further ado, let me go to the introduction about this online classroom. So this invited lecture series is a series that we try to invite experts and also excellent team within our community to actually speak some specific topic, or also to share their knowledge and also experience in our activities. So I hope that this series will actually inspire, and also will attract more teams, especially new teams, to join our activities, and also try to outreach this effort to more continent and also more region in this world. Okay, and apart from this invited lecture series, we also have regular online classroom track, which is available on our website. You can see. So currently we have one complete introduction to service robot that you can learn it with a span of 6 weeks. You can learn about in terms of Python, ROS. You can learn about speech, vision, and so on. And also we have the special track, which is previously we have conducted for our online challenge. So over there we have a lot of resources, like how to build the robots for the competition, how to build the robots not just for open platform, and also we have one which is the special series for Pepper robots, which is the humanoid robots by SoftBank Robotics. So for more details, please head to the website and you can find all the resources. So all the resources is open source, and you can find our YouTube video, you can find the slide, and also our example code that we use in the classroom available in our GitHub. Okay, right. So I think I have used up most of the introduction time. So now, without further ado, let me introduce our speaker today. So they are Team UBC Open Robotics from the University of British Columbia. So let me read out their biography. So it's an engineering design team primarily composed of undergraduate students in field ranging from engineering to computer science to art at the University of British Columbia. So this was the team's first year competing in any RoboCup competition. So despite receiving the Turtlebot 2 hardware mail weeks prior to the city lockdown, they were able to stay organized and effectively meet competition requirements, receive both the RoboCup at Home Education League's Silver Award and People's Choice Award. So below are the list of members. So I will let them introduce themselves, okay? Right, so I'll pass the mic to you. So Team UBC, it's the floor of you. So you can first introduce yourself and proceed with your presentation. Okay.
Thank you so much, Jeffrey, and thank you to the entire RoboCup at Home League and the team. It's amazing to have this opportunity. So my name is Nikki. Do you guys want to introduce yourselves?
Thanks, Nikki, for starting that off. I'm Kritika. So Nikki and I are the captains of UBC Open Robotics. Next, we'll pass off to get our leads to introduce themselves.
I'm Nick. I'm one of the software co-leads and also a fourth-year student in UBC.
So my name is Osman. I'm also one of the software co-leads, and I'm also a fourth year at UBC.
My name is Francisco. I'm on the software team and also in fourth year at UBC.
Hi, I'm Andrew, and I'm also a member on the software team. I'm second year engineering at UBC.
Alrighty, so I guess we can do some share slides showcasing a little bit about us. So the topic for our presentation will be taking up a challenge as an engineer, since we think one of the things that makes our team so unique is the fact that we are primarily composed of engineering students trying to tackle robotics challenges. So in this presentation, we're going to do about a 20-minute session on us as a team, and then we will do a 40-minute session on the technical side of the presentation. So that'll be the details regarding taking up a challenge as an engineer, and that'll be followed by a Q&A session for 20 minutes. So you may be asking, what exactly is open robotics? And that is a good question. So in this photo you see on the screen, that is a photo from last year. So you can see the size and the diversity of our team. We have students from physics, computer science, undergraduate engineering students, graduate engineering students, art students, and many more as well. So we have a very diverse team trying to tackle engineering and robotics challenges. So although we are a primarily engineering team, we are also supported by various sponsors and mentors that we are very fortunate to have. And so our mission statement. So our main goal as a robotics team is to create and develop state-of-the-art robots using our university facilities and laboratories. We also want to facilitate the collaboration of different disciplines and encourage our members to develop their hands-on robotic skills, since as university students, we are often taught the theoretical aspects of robotics, but sometimes in a little bit of a vacuum. So we really want to encourage those hands-on skills and make sure that everyone is able to work in a diverse team, a multidisciplinary team, when they get to the workforce. We are also very passionate about teaching our students who are new to robotics through a mentorship program. So last year, we launched our first year mentorship program, and we had tremendous success with it, and it's something that we look forward to doing every year, as we were able to take first years who are new to engineering or non-engineering students and teach them the basis of robotics and have them succeed in the team as having regular technical roles in the years to come. Another thing that is very valued in our mission statement is our use of our outreach programs. So the photo that you can see here is our team, some of our team members presenting at the UBC Engineering Physics Open House. And so that is one of the departments at UBC. And so we make sure that we are present as many open houses or various outreach events as we can possibly attend, because we think it is so valuable to raise the message about engineering and robotics and make sure that younger generations, and especially women who are interested in STEM and engineering, are able to see that engineering and robotics are accessible and also fun. So now a little bit about the projects that we do at UBC Open Robotics. So looking at our logos from left to right, we first have the Robot Art logo, and so that represents the team, that our Artbot team, and they will be aiming to compete at the Robot Art competition next year. Next, we have the RoboCup at Home logo, and so that signifies our RoboCup at Home team. And then we also have our Pianobot team, and so we will now do a little bit of a brief discussion on each team. So Artbot is one of our newer teams, and you can see on the right some of the pieces that go with our robot. So we have some of the we have a motor, we have some motor brackets, some ball bearings, and all of this makes up the lovely robot that you're going to see in this video right now. So here you can see our Artbot lead, Aiden, he is holding the end effector and moving around to show the range of motion that our robot is going to have. Now, you may be asking, what is this robot? So, good question. As the name may suggest, Artbot is a robot that is focused on making art. So, where our team lead's hand is, that's the end effector, and when the robot is complete, we're going to have the end effector hold a paintbrush or a marker or some sort of art tool, depending on the medium. And on the turntable that you can see at the bottom of the screen, we are going to be placing a canvas or a paper or whatever that the art is going to be placed on or drawn or painted on. And so, of course, this is a prototype, but the final product will be completely automated. And the end goal for the robot is that it will either create its own original art using machine learning algorithms or recreate existing art. And so the reason why we have these two genres is because we will be, or our Artbot team will be entering the robot art competition where they have multiple leagues. And so that competition is to take place next year, and our team is really excited for it. So on to the next slide, we will learn a little bit more about the challenges that our team is experiencing right now. So here we have a couple of our lovely Artbot members posing with one of their prototypes. So currently, unfortunately, due to the ongoing pandemic and the restrictions our university has around that, our Artbot members are not able to continue working physically on the robot. So because we don't have access to our lab space or any of our machining equipment, we unfortunately are not able to work on the physical aspects of the robot, but they are still working on some of the machine learning and code aspects right now. So hopefully once we have a little bit more access to our physical spaces, then we can get back into the groove of things and hopefully aim to compete next year.
All right, so now we will be moving on to the Pianobot project. So unlike the one that we've previously talked about, Pianobot is not focused on a competition. It's a project that merely came out of the interest of some of our upper year Megatronic students. And as you can tell, yes, this is a robot that is going to play piano. Their inspiration came from Teotronica robot. And Andrew, if you could play the clip of that, please. So yes, if any of you guys are music enthusiasts, you will know that this is the Turkish March by Amadeus Mozart. And while we aren't really sure if we're going to be able to get to that level for a little while longer, because obviously we are full-time students, we're balancing so many things on top of being on a design team, we do have some very well-fledged out goals. And that's what kind of makes Pianobot unique, is despite not being a competition team, they knew exactly what they wanted in terms of technical requirements, what they wanted this robot to perform. And based on that, in the last 2 years that they've been a team, they've been doing wonderful. So if you start by playing the first video, you can see that our robot can play the white keys already. It's Twinkle Twinkle. Oh, could you turn the sound on? Oh, there you go. Awesome, and if we play down below, you can see that it is also able to move all the way across the piano, hence being able to play all octaves. Yeah, so moving on to the next slide. So currently, this team is about 7 to 8 students, and one of the setbacks that we're now facing with this team is, as I mentioned before, most of this team comprised of upper year Megatronic students, and a majority of them have graduated just now during the pandemic, and they are going to be pursuing grad school, so they're not sure they'll be able to continue their commitment to the team. This means that we need to make sure we can, during this turnover time, find people to kind of take over their tasks. And we are going to be doing an online recruitment cycle with UBC in September, so hopefully we can fill in those gaps. The photo on the left, you can see solenoids, which essentially they convert electrical current into linear mechanical movement, and that's how the robot is able to move its fingers up and down. On the right, you can see one of our dedicated members coding something for the robot. Yeah, so moving on to our last project, the RoboCup project. So it is our flagship, and unlike the other ones, it's actually focused on two different competitions at the same time. So one is the RoboCup at Home General Competition, the Open Platform League, and then the other is the RoboCup at Home Education League, which we actually qualified and did phenomenally in this year. So a little bit about the structure. Our RoboCup at Home team has a hardware component and a software component. The hardware teams are working to build a robot from scratch. So there's arms, drivetrain, and gripper. They have mechanical, electrical, and firmware subteams. For background, firmware is essentially the lower level coding that is associated with motor control, for example. So that's what the hardware teams are doing. And what they do is once they have the low-level software and the hardware done, then they send all of their work over to the software team, who is able to take those libraries and put them into ROS, and they're able to kind of work with the machine learning and the higher-level coding aspects of the team. So we have not actually tried to compete in RoboCup at Home yet. We're hoping to do so next year. And because of the pandemic, it's been a little hard, especially for machining, because we did have access to the laser cutter, water jet cutter, all of that at UBC. But unfortunately, we're kind of locked out right now. So hopefully we can outsource that and still make our project requirements on time, but we will see. And then on the other end, we have RoboCup at Home Education. It's a smaller team. So they were able to acquire a Turtlebot only a few weeks before the pandemic started. So it was really amazing what they were able to do in a short amount of time with their very strong machine learning skills. And I'm gonna leave it to that because we'll be hearing more about them through the rest of this talk. Yeah, so here's a video of some of the RoboCup at Home gripper team members. Yeah, so since we have the gripper and arm team separate, the arm was being designed so the gripper team was kind of working on the amount of things they can pick up. And so as you can see, this is them testing various types of payloads. So, you know, we will definitely have something that's fully autonomous at the end of the day, but this is a prototype from a while ago. Moving on. Yep. So on top of that, as I mentioned, we have hardware teams and software teams, and we have a couple different sub-teams. So how do we keep everyone on top of things, and how do we make sure that people kind of know what to ask other teams? For example, if I'm on the gripper team and I need to ask a question about the wrist, I probably want to talk to arm, right? Because that's where it's connecting to. So in order to do that, we have monthly meetings called integration meetings, and this was our first integration meeting that we did over Zoom. It was a lot of fun. As you can see, we're all smiling in the photo. So this is essentially for us to discuss hardware and software specifications and any problems that one sub-team may have so that we can ensure a smooth integration, because we know that integration is probably going to be the most time-consuming and difficult part of building this robot. Next slide, please. Awesome. So here is a little sneak peek at what the education team has done. You'll see more later on. Yep, so this is handle segmentation. So essentially, using machine learning, they were able to successfully identify the handle of a backpack so that the Turtlebot could lift it up by that handle. So a little bit more about the history of our team. Our team was founded in 2012 as actually part of a different team. And you may have heard of them. They're called UBC Thunderbots, and they participate in a soccer playing league for RoboCup. But a couple of years later, they decided to branch off because we were really focused on RoboCup at Home. And things were going well until the primary administration team all graduated, and that's 2017. So that's kind of when a couple of us joined in first year, and we saw that there was kind of a need for more leadership and project management. And by 2019, we had restarted the team. And, you know, that's kind of when things started to pick up. We've gained a lot of traction in terms of our team name for other students, and people have learned quite a bit. And now we also have a competition win under a belt, so woohoo for us. Yeah, and currently we are just trying to figure out how our plans will be modified due to COVID restrictions. Yeah, so in the present and in the future, our main goal is obviously going to be building an affordable, versatile humanoid robot that can truly make a difference. So we do have certain projects, but our goal is kind of beyond that, and that's kind of just what we want to emphasize before we move on to the technical portion of this talk. Yep, so next up, I'd like to introduce the start of taking up a challenge as an engineer, our technical portion of the talk.
So here we're going to focus on the applications of engineering on our technical project, so our RoboCup at Home project. So the first question we have is, what is an engineer? And so, as defined, an engineer is someone who works in the branch of science or technology, and they work with design, buildings, and the use of engines, machines, and structures. All right, so you may be wondering, that kind of sounds a little bit like the work a scientist might do. And you're not wrong at all. So a scientist is typically a person who is concerned with the theoretical aspect of the world in its entirety. So scientists do research that answers various questions about the world, and then engineers apply those theories to solve design problems or anything of that nature. And so we can also see that engineering is very diverse, both in the type of people who are engineers and also the type of work someone could do as an engineer, and also the fields that they could work in. So on the row on the bottom, starting going to the left, we see some people who look like they are either environmental or civil, probably construction engineers. And then we look at some people at most likely a chemical processing lab, so in the field of chemical engineering, and then somebody who is soldering an electrical circuit, and that could be applied to many, many different industries. So we can see that engineering is super diverse and can be done in a lot of different ways. So the next question that we are trying to answer is, cool, we know about engineering, but why is it important? And that is a really good question, because as we learned in the previous slide, engineering deals with the entire world. It is the field of problem solving anything in the world. And so specifically dealing with robotics, we can see that many robotics problems or challenges are all problems that can be solved using the engineering design cycle. So we will talk a little bit more about the engineering design cycle in a couple slides, but what we can say right now is that it's a standardized design process, and it is tremendously important. So one of the reasons why it's so important is that it applies to so many design problems. And so a couple of different examples, we have the robotic social interaction example. So that's a commonly seen design problem in the field of robotics, and that deals with the interaction between people and robots. We also see the brain-computer interface, and so this is used widely in the biomedical industry, and it's the communication between a brain and a device. And we also have the problem of robotic swarm technology, and so that is a group of robots communicating together. Now, another question that somebody may have is, why are we using the formal design process like the engineering design cycle as opposed to a more arguably intuitive design process like trial and error? And so what we can say is that the formal process takes a lot less time most of the time, because with trial and error, you are implementing a design, seeing whether or not it works. Most likely, by chance, it probably won't work, and then you'll have to implement another design and then rinse and repeat. So this process can be very, very costly, both in terms of time and materials, and also money. So we know that the formal design process has a lot less cost associated with it, and it also is lower risk, especially when you are dealing with projects that are very expensive or even potentially have dangers associated with them. The formal design process is also very efficient, while the trial and error process or similar processes are typically quite inefficient due to the trial and error nature of the process. Also, because the formal design process follows a formal predefined layout, there are many opportunities for documentation in areas where you are required to justify your design. So then, in hindsight, when you have a completed design, then you have many means by which you can fully justify why you picked that design and why it is a superior design, as opposed to just saying that, oh, well, it worked, as you would in the trial and error method. So now we're going to learn a little bit about what the engineering design lifecycle is actually. Osman, I'm sorry to interrupt.
Yeah, your mic is not on.
Oh, sorry about that. Yeah, so I was saying, now that we discussed why it's important to follow a formal design cycle, I'm going to discuss the different steps in the design cycle. So it's important to note that this is not a linear process. That means there's going to be a lot of failure and iteration. So first of all, we start with the problem. So this is a challenge or a goal that we're striving towards. Now, after we define the problem and study it, we go into generating potential solutions. So this is the most open-ended part of the process. This is where you let your creativity go on. And after we generate all the possible solutions, we go into identifying the most promising solution. After that, we develop and test the different solutions that we identified. And finally, we implement the final solution or product. So next slide, we can see a different way of interpreting the cycle. So again, as you see, it's not quite a linear cycle. In the earlier stages of research, there's a lot of uncertainty. As you move on to generating concepts, the focus becomes more clear. There's still quite a bit of uncertainty and iteration. But then finally, once you select the final concept, you go on in a very clear and focused method, and you finally finish with the final design or product. So a very important part of the design cycle that you can see on the next slide is stakeholders and needs. So there is really no project without stakeholders, and essentially the whole point of a project is to address the stakeholders' needs. So just to define what a stakeholder is just anyone who's influenced by the project or who can influence the project. And the focus here is not really just knowing who the stakeholders are, but rather knowing what their needs are. And the needs in this sense are the requirements or expectations of the project by the stakeholders. So that's essentially everything that the stakeholders expect us as a developers to give them. It's also important to note, as a final note, that stakeholders can share the same needs, but can also have contradictory values. So it's important to be able to balance everything and compromise. So next up, I'm gonna discuss the stakeholders for our competition. So as you can see, these are the main stakeholders or the key stakeholders. There are still quite a few stakeholders, but these are the most important focus for our competition. So first of all, of course, the design team members. So that includes everyone on the software team, everyone on the Robotics team, and so on. There's obviously the RoboCup at Home committee and the community of RoboCup at Home, our sponsors, and finally the engineering design team committee. So that's as part of our university. So as you can see, the idea here is not to satisfy, or the idea is not to satisfy everything. You can't quite satisfy all the needs. We just have to focus on the key needs that most of the stakeholders share, and we have to satisfy as many needs as possible while still leaving some room for a compromise in case of contradicting needs or needs that we are not able to accomplish. So now that I discussed the stakeholders, I'm going to move on to the first main stage of the design process, so the problem. So what is the problem in our case? Well, the problem doesn't always imply a conflict or issue. In this case, it's something we're striving to achieve. So as you may know, for the RoboCup at Home education competition, we tried to identify and study the problem. And what we found out is quite simply the problem is to create robots that can help humans in everyday tasks. So that includes an example would be helping a human carry groceries or helping someone find a chair and so on. And obviously after that, we went into more details to analyze it. And after knowing the problem, we branched out into different problems or different goals. So more examples would be human-robot interaction, environment navigation, facial recognition, speech recognition, and so on. So after we identify the problems, we next study the problem. So we need to learn more about the problem and why we're addressing it and how to address it. So these are some of the key things we follow to study the problem in our case. So one of the most useful and probably entertaining ways to study our problem in this case is watching previous competition videos. So it's quite useful sometimes to learn from other people's mistakes rather than your own mistakes. And hence why watching previous videos was very useful to give us an insight into what we're going in. Another thing which may seem quite obvious but is often overlooked is the rulebook itself. I mean, the rulebook centralizes everything we need to know about the competition and the different challenges, the rules, and so on. So it's definitely probably the most valuable resource in our case. Obviously, there's also reviewing related research. So that could be research into human-robot interaction and machine learning and so on. And finally, communicating with the committee, which has proven to be very useful in our case, as they are obviously our main stakeholders. So keeping good communication and continuously asking questions has proved to be a very valuable resource. So next up, I'm gonna go to the next stage of the design cycle. So it's generating potential solutions. So as you can see on the following slide, there is something we call a solution space. So a solution space is essentially a way to represent how we generate solutions. And the goal here is to generate as many potential solutions while also keeping them diverse. So as you can see, there's three main metrics here. There's the time, there's the solutions, and there's the variety of solutions. So we want to try to balance all three metrics. And some of the common problems, as you can see on the top right, there's a problem of early stopping. And when you stop early, you don't really generate as many possible ideas as you can. So that means you could miss out on the best idea or on really good ideas. It's also possible that you completely overlook one aspect because you stop early. So it's important to know when you should stop. Another issue is the lack of variety. So in the bottom right, you can see that if we fixate or if we anchor, that means we can miss out on a variety of problems. So we may generate a lot of possible solutions, but they could all be the same in a certain way. So that also means we could miss out on the best possible solution. So, you know, overall, it is really important to balance the time, the variety, and the amount of solutions. And that goes to, that goes to some questions like how much time we have available, or how quickly are we generating solutions, or how good the solutions need to be. So after answering these questions and some more, we can be able to design a good design space, or solution space. So I'm gonna mention an example from our project on generating potential solutions. So for facial recognition, which is an important part of the competition, we first started by generating some potential solutions. So these are some of the options. I'm not gonna go into the boring details of what each one means, but these are different options for facial recognition or recognizing faces. So one thing to note is that at this stage, there are no wrong answers. So we really were trying to be as creative as possible and generate as many and as variable solutions as possible. And even one of the solutions that we considered is that we have no facial recognition. So we thought, do we even need the facial recognition? Can we get around it somehow? Sometimes the best solution is to realize there is no problem. So we thought, could we not use facial recognition? Obviously, it turned out that we need the facial recognition, and in the end, we did go with the CNN, which we'll explain why later. So next, we're gonna go into identifying most promising solutions with Andrew.
Thanks, Osman. So in the third stage of our engineering design process is we are identifying the most promising solutions. So just to summarize a little bit from what we've already seen, so what we have already done is that we've clearly identified the problem through analyzing the stakeholder needs, right? So, and through that, what we've done is we've constructed a set of targeted design specifications, which is number one, some requirements, or in other words, it's applied to the final product, and some evaluation criterion. Or in other words, you can call them characteristics of the end product, which can be evaluated based on a gradient or sliding scale. So not only have we clearly identified the problem, we've also generated a large set of possible solutions while avoiding fixation, and anchoring. So it was important in that stage to consider all the possible solutions, right? We didn't know which ideas were weak and which are strong, and we also had to resist that generation stage, as it could limit the variety and the creativity of the ideas created. So now we've generated this large solution space. We can pare down on the solutions or the products, the designs that we have, until we have a single or a few very products with the most potential. So as you can see, this is sort of a visual representation of what that could look like. I hope we can all see what we're trying to communicate here and the importance of the engineering design cycle. So the darker circles represents ideas that have the better solutions. The better they are, the darker colored they are. And as we go through the 4 steps that we have here, screening, ranking, scoring, and finally selection, slowly the pool of solutions shrink until most. And again, the engineering design cycle is akin to like the scientific process in which we optimize the design process and ensure that additional resources and time is not wasted on ideas that might not make it to the final selection. So this is not only applicable to the robotics challenges that we faced for our particular RoboCup at Home project, but for any design solution. So again, the goal of this step, identifying the potential solutions, is to narrow down from all the possible solutions that we had, the large variety, to identify the solution that we need to be developed further. So just to focus a little bit on the 3 stages that we mentioned, we have screening, ranking, and scoring. So these are maybe some new terms, but let me just go over what they mean. So firstly, we compare the designs that we've come up with to the requirements. And if any of them don't meet the requirements, then we remove them or eliminate them. And we should look to see if there's anything that we can do to modify the solution. So eliminating solutions that do not meet the requirements is known as, so anything that does not, for example, meet the minimum or maximum technical specifications, we simply discard it. And we only recover ideas that may be improved or tweaked a little bit to meet these requirements. Then this might cut down your solution space by a lot. But now we have ranking, which means to roughly or qualitatively rank or sort the ideas that we had from strong to weak. So top ideas in ranking in that way, we'll analyze a little bit more, maybe through the process of prototyping or simulation, which we'll get into further. Of course, in ROS, there's Gazebo that we can use. But some problems that we can face here is that if too many ideas pass through ranking, there could be a lot of extra work to analyze these ideas. If there are too few that pass through ranking, we might overlook the top ideas. So in order to use some formal ranking methods, then we can avoid what psychologists call groupthink and promote the diversity of ideas. So let me just quickly mention some of the ways you can rank. So let's say we have 10 or 50 solutions. A few ways is individual voting, which everyone on a team who has an understanding of the problem, each person has a certain set of votes to allocate to each idea. So for example, if design A is I like the best, so I would rank it as first. And then if somebody else might rank another idea as first. And then based on what ranking each idea got, they will be given a series of points and they can be tabulated in order to come with the best idea. Quickly mentioning some other methods, such as board account. You can search these up later, is if each person ranks each and paired with each other. So if, I can rank each idea on a scale like 1 to 4, so on. Piecewise comparison, in which each design, so design A, for example, is ranked against design B, and then you can check design A, design B, and design A is compared to design C, and so on, until each design is compared with each other. This is called piecewise comparison. And finally, we can also do it by criterion. So ranking, as it shouldn't be a very detailed, but it's a very fast process in which we shrink the pool of ideas and sort of filter off, skim off the cream of the crop to move to scoring, in which we assess the designs that have passed through screening and ranking based on the evaluation criterion. So the requirements set out causes us to screen out ideas that don't meet them, and the evaluation criterion, again, it helps us to quantify the relative performance of each idea and score them in order to come very close to the final selection. So one of the tools that is very useful that we use in scoring is what we call a decision matrix, or a WDM. So if we take a look at our evaluation criteria, we would have set out some metrics. In other words, what are some things that are being measured? And we'll see on the next slide. And how those measurements can be translated to scores. These scores can then be weighted on a, generally speaking, 0 to 10 scale, where 10 cannot be further improved for satisfaction, and 0 is minimally acceptable. This 1 to 10 score relates with the metrics that have been set out. And we should also note that a score of 10 should not be attributed to a concept with the best results, but should be given to those concepts that fully satisfy the stakeholder needs, to a point where any additional improvement does not necessarily impact the satisfaction significantly anymore. So just going over this chart, as we can see, we have three designs. This is just an example: design A, design B, and design C. And we have 4 criteria, A, B, C, D, right? And they're weighted based on how important they are to the stakeholders. And this, again, the weights depend on the stakeholder priorities. And we'll see some examples later. And just a few more points. A decision is what we call robust if we can change its weight around, right? And the ranking of the scoring does not change wildly. So again, we also only use weighted decision matrix on good ideas with a good chance of success, because they have passed through screening and ranking. So perhaps we'll see some examples, and this will make this more clear. So here are some examples from our RoboCup at Home experience. So as we can see in the top 2, these pertain to some criterion that we had in speech recognition and analysis. So for example, the first one, the first graph shows the number of recognizable commands. So 0, a criterion score very low of 0 would be if we could recognize no commands. And of course, we wouldn't be satisfied with that, right? But as we can recognize more and more commands, the criterion or the satisfaction score rises until on this graph, it plateaus. We notice that it plateaus, and it plateaus at a certain point because for this specific competition guidelines, there will be a point when there's no more needs to recognize even more commands, right? But of course, in the future, and it is closer to our eventual dream of building a more general purpose, fully autonomous service robot, this plateau will be less and less flat, right? And we want more and more commands. And again, we also know that these are linear, which are easier to calculate, right? But they don't necessarily have to be linearly correlated. On the top left, we see accuracy. So maybe our robot could recognize many commands and is able to parse many different sentence types, but this might cause a decrease in accuracy. So this is actually what we've noticed. For example, one of the examples that we faced is when we were trying to get the robot to follow someone and then stop. The stop word is quite important. I think there's a blooper later on showing something happening that's not so good if the robot doesn't stop when we tell it to, right? But as we can see, as the accuracy gets lower, the satisfaction score, of course, also gets lower until it plateaus at a certain point where we're no longer satisfied. We should also note that even though, now that we've explained it, the number of recognizable commands and the accuracy, they might be a little bit correlated, right? As our corpus grows, sometimes accuracy could be worse. but they are not on the same graph, as in this way we can objectively measure each of these specific metrics in comparison to each other. Some other examples that I included are some other shapes of graphs in satisfaction that we may see. For example, in the RoboCup at Home rulebook, we see that in obstacle navigation, if there are any damaged objects, then you won't get any points for that, right? So you can't have any damaged objects, so therefore our satisfaction drops to 0 immediately if anything is damaged. And another final example is on successful pickups for the arm. So we used the move it commander in order to use the arm, but there was still many different methods. For example, you can specify coordinates, or you could increment where you are towards a certain position where we were supposed to pick up the bag. But because of the way that the move it works, sometimes for put in a coordinate, the arm might go all the way around, and then so we might have to set waypoints and use other methods in order to pick up this bag task, right? That's why we one of the things is we look at how many successful pickups we could do in almost like an experimental fashion. So we are not at all satisfied if it could not pick up. We have very low pickups, but our satisfaction grows as soon as it meets our minimum requirement, until it eventually plateaus at when it's quite successful at picking up all the items that we tell it to. And this is an example of the WDM, or the weighted decision matrix again, that we use for the person tracking algorithm selection. So again, here we can see, for example, the weights. We valued very highly the accuracy and the speed of the algorithms that we were going to choose, right? And some of the methods that we were selecting from are the hard cascade, using hard cascades, a custom trained network, YOLO, and also YOLO plus an OpenCV fast tracker. So again, we see this weight is quite important. Oh, I forgot to mention earlier, these weights should add up to 100%, right? Because if we're fully satisfied, then it should 100% of the weights should be satisfied. And again, the weight is important, as we can see here. YOLO by itself, its accuracy is higher than the YOLO plus OpenCV fast tracker, which we eventually ended up adopting, right? It's also more easy to use in general. However, because we weighted speed quite highly over ease of use in generality, the speed of the YOLO plus the OpenCV fast tracker gave it an edge over all the other methods. So again, we have the raw score, which is on the left-hand side, and then the weighted score, which is the raw score times the percent of the weight, and we can finally add up all the weighted score from each category and compare each selection with each other. So just to summarize a little bit for this portion about identifying the solution with the most potential, this is a kind of a little graph that sort of looks like how many solutions you may have as you go through this selection process. So first, we see a large jump as we try to generate as many solutions as possible, and then many of them will be pared down in the process of screening, where you'll be able to recover a little bit, and then in ranking, you will, of course, skim off the top ideas, and then finally, in scoring, you will get very close to your final selection. And again, this process you can repeat more than once depending on your situation, and there will be many chances to iterate along the way. So just finally, from our project, to assess the facial recognition, as mentioned from the previous step, we use a few strategies. So even though we still fell a little bit into the trap of trial and error, in addition to that, we also consulted our mentors who have many years in computer vision and experience, having performed similar projects. And we would also like to thank them because they were a great resource for our insight. They also had the experience with all the different proposed methods mentioned earlier and have a clear idea of which one is best based on the context. And lastly, it was very useful to review the research, which was available online, especially one that compares the different and highlights the advantages of each. And in addition, we reviewed previous description papers by teams that have already attended the competition. So we move on to the next step after we identify the most potential solutions, which is to develop and test these solutions.
So the fourth stage in the engineering design process is developing and testing the solution. Now, by this point, we have already generated and identified promising solutions, and now we need to be able to develop this solution while keeping in mind that the goal is to minimize the overall risk. And now this, in general, can be done by the use of prototypes. So a prototype usually refers to a first implementation or a preliminary model of some concept or idea. It's a very vague term. And here the goal is to be able to test the solution that we generated and catch any issues before their impact on the project is too great. Now here's a qualitative graph that shows how as the project progresses in time, risk and our costs raise for every error that occurs. So we want to try and prioritizing catching errors early. So it's important to categorize prototypes into different kinds so that we know which ones to employ and to what end. So here on the right, we have a sort of graph of the different axes of prototype classification. We have two main ones, physical versus virtual, and focused versus comprehensive. Physical and virtual are fairly self-explanatory. In general, physical prototypes pose a higher risk, either because of incurred costs or longer development times. And focused and comprehensive denotes how specific the prototype is. For example, if we want to test a single concept or an idea, that would fall under focused. Whereas once we start integrating hardware and software, we would start to move more into the comprehensive kind of prototype. And the red arrow going from bottom left to top right demonstrates how prototypes should evolve with time. That is to say, we generally want to start with a very focused and mostly virtual prototype, such as sketches or in the software side, individual Python scripts just test quick and dirty ideas, stuff like Jupyter notebooks and that sort of thing. And then as time goes on, we progress to much more complex and physical prototypes, such as testing competition-specific tasks on hardware or the final robot itself, which is the most physical and comprehensive. Now, the purpose of this approach is that focused and virtual prototypes pose the least risk to the project, and so they should be tested first to catch any glaring errors. And then as we move towards more physical and comprehensive, we can test more risky ideas because we've already done the groundwork that is required to reduce the risk. As a recap, in early stages, prototypes should be quick, inexpensive, and simple. We're trying to explore or question, and when we progress to the later stages, prototypes are more detailed and accurate. We're trying to refine and describe and just try and implement our final solution. Now, for a more specific example, going back to facial detection and recognition, one example of the different stages of prototyping is how we approach this problem. Early on, we tested simple hard cascades. These are implemented very quickly in Python, but they don't perform very well, especially given the fact that they can only do facial detection. They can't really do recognition. But it was important for us to start at this point because we were able to test a simple concept quickly and risk-free. After some time, we moved towards convnets, specifically CNNs with a softmax classification output. These served simply to test our understanding of the basic facial recognition and proved to be more accurate with a still reasonably small time to implement. These they do not have the accuracy of a final finished implementation because they still require a lot of setup and legwork. Finally, the actual implementation, we took a pre-trained VGG16 model and we did some transfer learning to train the last couple of fully connected layers to get a feature encoding network, which was definitely the most accurate of our approaches and took the longest to fine-tune and perfect. So using this approach, we were able to test various ideas and refine our implementation while minimizing overall risk. Next, with prototyping comes testing. So Testing allows us to determine whether certain ideas, which are implemented through our prototypes, can actually accomplish or prove to be functional while minimizing any future risk. In our project, testing comes mainly from ROS and specifically Gazebo, and also physical testing by replicating competition tasks and environments. Now this comes down to implementing features in software, running simple scripts in Gazebo to test very specific functionality, and which was very useful, especially when we didn't have access to the actual hardware that we required. Now, once features are tested, we can iterate on our algorithms to improve performance as well as to smooth integration along the line between different modules and different features. Additionally, we test hardware under competition-like conditions, such as attempting the competition tasks themselves, which reduces any unexpected issues we would face in the future and allows us a reasonable estimate of our progress. So finally, the last stage is implementation. Now at this point, we have thoroughly thought of any ideas, identified appropriate ones, we tested them with prototypes, and now we move on to the actual final implementation, which is the culmination of the entire engineering design cycle. Now implementations can be very diverse depending on the field. So in this case, we just have different aspects of our specific project and how the engineering design cycle led to these specific accomplishments. By following the engineering design cycle, we were able to effectively reach several key milestones in the development of the final robot, which we see here. We have tests of the arm manipulation for the help me carry task, for instance. We have person following, as well as empty chair detection, and also have handle segmentation. And one thing that's not included is obviously speech recognition, which also plays a big part, but we can't really show that through GIFs. Now, I'm not sure about you guys if the GIFs have been running. But yeah, so that concludes the engineering design cycle. And now we move on to team management.
All right, thank you for that introduction, Francisco. So the reason that we're discussing project management is for one very key reason. You now know how to go through with the engineering design cycle, but having a technical background isn't enough. And the reason for that is you could be super knowledgeable in the technical side of things, and what that's going to end up doing is your ideas are going to go wild. You're going to be thinking all over the place because research is emerging, especially in robotics, you know, especially machine learning. There are papers coming out every single day. If you stay in the engineering design cycle too long, then you're not really going to be making progress on finishing a project. And that's why you need some very important people called project managers to kind of make sure that someone is keeping you grounded and making sure that you are sticking to deadlines. And another reason for that is because funding for a lot of companies or research places come from being able to show their deliverables at a certain date, or for competition requirements, for example. If you don't have something done for October, then maybe you can't make the qualification for the upcoming RoboCup competition, right? So that's why we're going to discuss two really key points that are methodologies in software, but we use them for our team as well, at least a modified approach. So the waterfall methodology is something that was developed in the 1970s, so it's super, super old. How this works is that usually this starts with a lot of research. You define your problem, you do tons of documentation regarding potential solutions before you get into any technical stuff. Then you finally start going on to building. As you can see, it takes quite a bit of time for you to get to even the build step, and that means that your risk is going up exponentially. And finally, you get to release, and once you've released your product for the very first time, your risk has gone up, but you've gotten a lot of value out of the project. And that's why, I'm not sure how long ago this was invented, but it was in the 2000s, I believe, when a group of technical giants came up with the idea of agile methodology, in which you start with some sort of burst of energy, you define a problem, you start building right away, and then you do a release. So now there's a bit of risk because obviously you are doing some exploration, and in a very short time period, you're kind of releasing a product. And this doesn't have to be an external release. This could be internally in a company or in a project setting. So you're doing a release, you're getting some value. And following this cycle means that you're doing documentation for things that actually work. So you're not spending too much time working on something that might end up leading to dead ends. And also you can get quite a lot of variety out of these types of projects. So Agile is something that we also use within our team. There are a couple types of ways to implement Agile. So let's talk about Scrum. Yeah, so I don't know about you guys, but when I was younger, I've always heard the terms Agile and Scrum together, but I didn't really know what the difference is. So Agile is actually a way of implementing, Scrum is a way of implementing Agile methodology. And what that means is that you have input from your stakeholders, so that could be your customers, your team managers, etc., kind of like we've talked about before, and you end up with a product backlog. Now what that backlog is it's just a list of tasks, all the things that need to be done, organized with priorities. For example, maybe one of the main features is to have an on and off button. That could be critical to do, but maybe something that's not as important as changing your background screen on your app from orange to red. So as you can see, you start by coming up with a huge list of things that need to be done. You kind of rank them with your group, decide what needs to be done first, what needs to be done later. And that's done in your sprint planning meeting. And your sprint backlog is, it's like a sprint. When you're doing a sprint, you go on a fast burst of energy, you just run quickly, not for very long. And that's exactly what a sprint is. A sprint is usually between 1 week and 4 weeks, and it's for a lot of design and prototype work to be done. So you're going to go into this and you're going to do designs, all sorts of things, kind of like what was mentioned before in the engineering design cycle. You're going to do screening, ranking, scoring, however you need to proceed with it. Your sprint master is essentially the project manager who's kind of keeping the sprint together, making sure that people aren't deviating a little too much from what needs to be done. So another way to kind of enforce that is daily stand-up meetings. Now, a daily stand-up meeting is essentially a meeting where your entire team meets. It's about 10 minutes every single day of the work week, or however your project meets. And you just kind of discuss, I've done this, I haven't done this, this is what I'm going to do today. So this way people have an understanding of how well the project is actually progressing. Because oftentimes we tend to be very, very ambitious and we think that we can get 5 tasks done in a week when maybe it's more realistic to say 3 tasks can be done in the week. You do a sprint review to kind of review the progress, as I've mentioned before, and then you finish your work. And that's kind of what Scrum is. So now I'm going to talk a little bit more about how our team implements these. Yeah, so we have a couple of different aspects that we want to address in this. We have documentation, stand-up meetings, sprints, and collaboration. Yeah, so documentation, for example, this is one example of documentation that's done on our team. So this is for project proposals. So this is one reason where waterfall methodology might be a little bit more useful than Agile. And the reason for that is if you want to start a new project on our design team, right, you need to think of a lot of things. You need to think of the funding involved, how many human resources you'll need. Like, do you need people who are more into electrical engineering? Do you need people in software engineering? Do you need some designers? What exactly do you need? So this is something where the waterfall kind of methodology is a little bit used in our team. And so here is a project proposal template to kind of have all of that laid out. The only difference we have is that we don't focus too much on spending a month on this, for example. This is a one-time thing. You finish this proposal template, fill out all the fields, do the research, then you have a meeting with the co-captains, and then we discuss the viability of your idea. So it's very collaborative, and that leads to my next point. Yep. So this is an example of one of our stand-up meetings. Yes, nobody here is standing, but the stand-up meeting doesn't necessarily mean that you're actually all standing. So essentially, it's just super collaborative. It's a short burst of energy where everyone is discussing lots of ideas or progress that's being made, as is indicated in this photo. Next slide, please. Great. So sprints for us are a little bit different than the rest of the methodology. And the reason for that is because we are a team of full-time students, and studying for our undergraduates or masters in engineering or other fields, we're quite busy. Our courses require a lot of work, and so we understand that it's good to have a balance between our studies and academics, as well as our extracurricular activities like robotic development. So for that, what we like to have is sprints, and a sprint we might have in the beginning of a project. For example, we have build days, in which the team comes together and you have a small design task and you have a few hours to implement it. Now, this might not be build a full-out robot in 2 hours, because that's not something that we're expecting, but this is something to kind of get our creative juices working, and so that people can kind of learn how they work with others on the team and to promote creativity. And then sprints are also for right before a competition, when people are kind of in a rush to get the last few requirements done. Yeah, next slide, please. And then we also need some ways to enforce that tasks are actually being done, because there's a difference between saying I've done a task and between actually doing it and having everything ready to go. So this is us using Trello. Trello is a project management tool. And so this is our admin team. We've chosen to kind of put that up because we've got a lot of members and lots of color on this one. So I thought it'd be the most appealing slide to put in. So as you can see, there are different labels associated with different aspects of admin. For example, on the left, you could see Google Drive management is one. There's finance, mentorship, inventory, finance, again. So there's a lot of variety within tasks on the admin team. And this way, we kind of have labels as to where our priorities are, what exactly we're focusing on. What's unique about how we use Trello is that we have a meetings tab, which isn't standard for most project management. The nice thing about Trello is you can kind of choose what you put in, but as standards and based on our own experiences in design companies for our co-op terms, we know this isn't standard. The reason we do that is just to track how many meetings people have and to make sure that people aren't doing too much of the meetings and getting burnt out, and just so that they can also get some technical experiences at the same time. Another thing that's really cool about this is that you can have dependencies. The cool thing about a dependency is, for example, you may have a task that depends on task A being completed. For example, if I'm going to make a hoodie order, perhaps we need to first reach out to a company and make sure that we have the right sizing requirements for those hoodies. So that is a dependency, and that's also something we use to keep our requirements kind of more manageable.
Awesome. So now we're going to go over the next slides. We're going to go to see two more concepts of great importance that we should always keep in consideration when designing a product and tracking the deliverable progress of our team. And by product, we of course mean any solution we're implementing that is meant to solve a real-life problem. Starting with a minimum viable product, or simply MVP. The idea of MVP comes frequently, especially in startups, because it targets a very common problem of efficient allocation of limited resources, such as time and money. A minimum viable product is essentially the intersection between the specifications of a product that we could develop as fast and cost effectively as possible, and the specifications of the ideal product that we would develop if we had all the resources that we wanted to. Of course, this is not only applicable to startups, but to any project that has resource constraints, such as the online competition at RoboCup at Home Education that we just participated in. As seen over the next slide, this concept allows us to stay focused on some minimum requirements that our product should meet, and saves us from the common pitfall of anchoring and allocating more resources and improving one specific aspect of the project while undermining the development of others. For example, while developing and training a model for facial recognition, although it would be awesome to achieve 99% accuracy, it would be inefficient to continue researching architectures or tuning hyperparameters when an 85% accuracy meets the minimum requirement goals for the task. Now, moving on the concept of resilience. In industry, the term resilience is defined as the capacity to absorb or mitigate the impacts of hazard events while maintaining and restoring critical services. What this essentially means is that when developing the solution for a real-life problem, we should take into account factors that could affect either the implementation or the performance of the solution/product, and adjust accordingly in order to be able to deliver the minimum requirements as we talked about before. The concept of resilience can be applied in project management, where a good habit for designing a project timeline is to overestimate a bit the resources required for each task. And again, by resources, we mean time, money, or even number of people working on the task, and set a deadline of the project deliverable on a considerable amount of time prior to the actual deadline. For example, when looking on the impact that the pandemic had on our project development for the 2020 competition, It forced us to work remotely without access to the engineering labs, as well as it delayed the deliverables of many tasks we had planned. But thankfully, because we had overestimated the required resources for the project deliverables and early defined our minimum requirements, we were able to meet the expectations of the project. Another great example of a resilient system is how the RoboCup at Home Education Challenge was able to switch in such a short manner to an online competition, in contrast with many other events or competitions that they were simply canceled. Of course, we do not only look at building resilient systems in project development, but in any field that can have hazardous impacts from external factors. In machine learning, we tend to use the term generality to describe the resilience of an algorithm. And it is about how the output would be affected if we slightly change the input. For example, if we have, again, a facial recognition model that is expected to identify me, how would it be affected if I wear accessories or if I change my facial expressions? The purpose of this talk has been to provide an insightful tools used in engineering design. Although some of the listeners today might not be engineers, engineer design thinking can be applied and should be encouraged regardless of your background. We hope this proves useful to your future projects and helps you avoid some of the common pitfalls when tackling a new challenge. At this point, we would like to thank the sponsors, MathWorks, SoftBank Robotics, and Jupiter Robot for supporting the online RoboCup at Home Education Challenge that we participated in. And of course, you, Jeffrey, and RoboCup at Home Education for promoting such challenges and educational platforms, as well as inviting us to this lecture today. If you would like to connect with us, you can follow us on our social media pages by using the links or QR codes on this slide. Thank you again for listening to our talk.
All right, thank you. So I hope my audio is back, and let's proceed to the Q&A, right? Okay, so maybe put this up. Okay. Okay, right. So I would like to invite all of you to turn on your webcam so that we can proceed to the Q&A, which is an interaction session. But before that, I would like to say thanks to all of you. Okay, I'm not sure if everyone can appear. Okay, so maybe see your face will be better. So maybe I not sharing. Yeah, I think like this will be nicer, right? So right. Okay, so thanks a lot for the very interesting lecture, and it's very amazing. I mean, like I'm very surprised with the content. So, and I never expect that you have done a lot of project management, and you quantify all the tasks, you analyze the whole thing, and develop everything in an engineering approach, and do a lot of scientific explanation and definition on the work that you're doing. Because that is something that out of my expectation, because I thought you would like talk more about how you do image processing and so on. Okay, but that is very I would say it's very interesting, and I have a lot of questions that I would like to interact with you, right? So first thing first is like maybe go back to your organization. I would like to know, like maybe I missed that part, like how big is your organization actually? I saw the photo, so you maybe like about 20-30s, and what is the distribution? So how many mentors you have, how many seniors, and what is the composition or distribution of different role among your groups that you can do all this project management, and how you manage between project management and technical development actually?
Yeah, so that's a really awesome question. Thanks for asking that, Jeffrey. So our team, at least pre-COVID, was actually around 60 people.
Wow.
And so, yeah, it's a lot bigger than it seems.
Okay.
Yeah, so the distribution is primarily engineering students, as we mentioned previously. We do have some science students, primarily computer science, We have 1 or 2 art students in our administration team. We did have some business students, and then they got busy, so hopefully we can recruit a couple more, because we do really encourage diversity. And we think that robotics should be accessible not only to, someone in computer science or someone in engineering, because that's putting up divides and borders that we don't think are fair. And to kind of get a better sense of robotics, we think diversity is really important.
Yes.
So, yeah, in terms of the actual division of people, though, yeah, as you mentioned, mostly engineering, and there's a lot of guys on the team. There are not that many girls on the team, which is something, again, we're also promoting. There's probably, I don't know, it's probably 20% girls, something like that, as a rough estimate. And as for mentors, we have about 4 industry mentors. We have Kujin Pei, who we've mentioned, helped with the software aspects and machine learning. And we have a couple of others who are helping more with the hardware teams and mechatronics. So that's kind of the primary composition. And then in terms of why we kind of stuck with project management, so the story kind of goes that a couple of us joined the team in first year, and we found that there was a lot of technical detail, and it was a jewel in terms of the technical aspect, but the team definitely had some things that they needed to improve on in terms of communication and project management. As I mentioned in my section, one of the downfalls that teams can have is that they have so many technical ideas, but then they don't really put like a cap on when to kind of stop and when to kind of proceed with deadlines. So we found that that was a huge issue with the team structure. And so when we kind of came forward as administration roles or kind of as leads of the team, then we kind of decided that we would be the ones to implement it. And recruiting a lot of new people, it's kind of easy to incorporate that project management and understanding for them, because they're joining a team, they don't have any expectations right off the bat. So you kind of mold the expectations that you give to them. Does that kind of answer your question?
Yeah, sure. I mean, like, yes. But okay. So maybe I would like to know more about, like, from this point of view, how many actually are undergraduate and postgraduate? What is the composition?
Postgraduate, we have a small handful. I think at the moment, I can say 1 or 2. We had a couple more in the past. So right now our team is, some people are on break or on leave due to COVID. But in terms of how we are able to do the project management, is that, so we have our 3 main project categories, as we mentioned, and within that we also have our RoboCup project being split further down. So with that we have sort of 6 projects. With these 6 projects, every project has at least 1 technical lead or a project manager, as you might say, and sometimes we may have multiple project managers. So for example, some of our teams have, sub-teams have a project manager for the electrical side and for the mechanical side. And so that way we have about 10 to 12 project managers on our team. And so they're focused on, they do like project leadership in the sense that they are also responsible for overseeing the technical aspects of their team, but they also do a lot of this documentation. And so Osmond and Nick are 2 of our awesome leads, so maybe they can speak a little bit more about how that is on from their perspective. But something that's really awesome about this sort of style is that it's quite flexible, and also that the documentation and all of some of the Trello tasks that you saw earlier, all of this is dispersed over numerous sort of levels on the ladder, so it's not just the captains doing all the project management.
I see. So mainly undergraduate students, and you have like leaders among you guys to actually lead all the subgroup, right?
Yes.
Right. So it's very amazing that undergraduate, because like being graduate from high school, and you start to like self-organize yourself, and while picking up your very busy schedule. I understand the workload of undergraduate, so my student always complain to me, and on top of that you guys have the motivation to actually do until this extent to even do documentation. That is something amazing. So I would like to know, like, what kind of organization of this UBC Open Robotics in your university? Is it considered a club, or I'm not sure, like, what kind of organization within the university? Do you have any idea?
So, oh, no, do you want to go ahead, Nikki?
Yeah.
Okay. So we are considered an engineering student design team, and that's actually a separate category at UBC. So actually, I think a lot of, at least, I'm not too sure about other continents, but in North America, it's relatively standard that at universities, there are like different teams of students in engineering on different kind of project requirements. So for example, we're a robotics-based team. There are other teams at our university that focus on rocketeering, or chemical engineering, or other stuff like that. Most of them are kind of working towards some sort of competition, but there are a couple that do not have competition. So we're a bit of a hybrid team because we have competitions and also projects not associated with competitions. But yeah, and we're fully student run. The engineering faculty, they provide bursaries and funds for us to apply for. And that's another reason we have to do documentation, because we need, when we're applying for funding, if we have documentation to kind of prove what's been going on and kind of organize us, it'll be easier for us to reach out and hopefully get more grants and more money, because again, it's a little hard sometimes to delve into robotics when you don't have the financial means to do stuff like that. That was one of our problems with the Turtlebot. You see Nick is smiling there, because that's one of the reasons why our Turtlebot came in so late, only mere weeks prior to the COVID situation, is because we were waiting for a funding grant to go through, which we luckily got.
Okay, so I think like it's correct for me to say like this is something like a student team or organization in your college. I'm not sure how to put it. And then it is recognized by the university or the college, and also
Yes.
I'm not sure like where the money come from, because you said that you can apply funding. I'm not sure like whether that funding actually consider student activities or research funding, but I guess it's more towards the student activities, right?
Yes.
So that is how it works, because like I understand like you need to spend a lot in order to like develop for robotics projects and so on. I understand. I have been struggling for funding myself as well. And I've been like observing what kind of model that different teams from different country, different university, how they actually manage the team, and I observe quite a different model over a different region. So you guys seems to have a model that is workable, and it seems like it worked pretty well in your organization. And how about the labs access and all those things? Are they like provided under your department, or your, for example, like if you need some machining, like just now you said about all your, I'm not sure like what machine you have, 3D printers, laser cutter, and all those kind of things. I'm not sure. I don't think you bought those things, right? So it should be like part of the department and so on. So I think you are student groups or student clubs in a more widely used term. Student clubs that driven by student, but it's backed by the department, and then the department actually fund your activities. So is that true?
Yeah, so just adding on to that, so regarding the machining costs, we pay for the cost ourselves, and so
Yourself?
some of that. So sorry, regarding ourselves, some of that is through grants, and some of that is out of pocket. But the department does not pay for it necessarily, but we do have access to the machines, like our CNCs and our laser cutters. None of those belong to us, they belong to the university. And so we, the engineering department that we are part of, they graciously allow us to access these items in these lab spaces.
Okay, so the reason why I share this information, or I try to ask a lot of questions about this, is like I think this information is very important for newcomer. For example, like if this video eventually like watched by some university student or some teams that would like to do something similar, they would like to see how to set up a work, not to say workflow, a framework that they can work in their university. So or maybe this video may be viewed by some faculty members or some university or some teachers and so on. So I would like to actually share, because like for RoboCup Education, our one of the very important mission is to outreach this thing. So I would like to document down all these successful stories. So you guys have been done a great job that create this very nice architecture or system that enable you to actually do this kind of development in a very structured organization. So that's why I would like to know more like all these things. So just now you talk about the sponsor. So are you actually approaching the sponsor as a stakeholder, or the sponsor are actually come from the college or department? Oops.
So regarding sponsors, we have an administrative team that they do a lot of the outreach stuff. So what they do is they contact prospective sponsors, and that's how we have found most of our sponsorships thus far. I can't say none, but all but one of our sponsors are external from the college or from UBC. So the one sponsor that we have that is attached to the university is the Faculty of Electrical and Computer Engineering. And they're also very gracious, where they allow a small amount of money per electrical and computer engineering student on our team. But that is, compared to the costs that we have associated with our projects, that is a fairly small amount. So we still need to find external sponsors.
So you are allowed to find external sponsor as well for your activities, right?
Absolutely.
Okay.
It's encouraged, and because we're one of the newer teams, in the sense that our administration changed, so it kind of sounds like we're a newer team. It's been kind of hard to get sponsors, so that's one of the things that we have been working really hard on, and our admin team has done a wonderful job. And we're still looking for sponsors, and we're hoping that now that we have this win under our belt, it kind of gives us a little bit more credibility as a team, so that we can get more sponsors. And if any sponsors are watching this, you know what we're looking for.
So you see, like over here, we would like to use our organization and our network to help you guys to connect with the sponsor as well. For example, like we work with Masswork, which is a global sponsor for RoboCup, and you got the goodies from them. And then we work with SoftBank as well. SoftBank Robotics is another big sponsors of RoboCup. And this company, they actually would like to see if there is any opportunity to collaborate with academics, because like when I talk to Masswork and when I talk to SoftBank Robotics, they have departments that work on education, and this is the things that they are concerned. But how much they will sponsor, that is another story, but they are concerned about this kind of development. So in RoboCup at Home Education, we try to come up with a framework that we want to show, like just now you said, like you have a very nice very scientific way to actually list down or define the stakeholder needs and how you achieve it. And you said that you focus on the documentation because you want to apply for funding, and these are all the things that people are looking. But the thing is, like on student level, this kind of things is very not so visible to the sponsors or to the outsiders. So we in RoboCup Education, we try to make your effort and all these things visible to outside, and also to actually attract possible, for example, like when we work with other people, when we work with any corporation or any organization externally, we would like to show them what our students is trying to do, and how all these things actually can make an impact, or is something that they are looking for. So if that happen, then maybe we can actually help to bridge and also to help you connect to the sponsors, right? So that is what I would like to see. And because like you guys are in Canada, and we have teams in North America as well, and also we have teams in Mexico as well, and actually it will be nice for you guys to have more organization among North America region, so that we can try to find local sponsor in North America to actually support your activities in a more bigger scale. So for example, like you can propose some workshops that you can ask all the neighboring teams to join, and then you have some event locally over there. And because sponsors, when they want to sponsor you, they are expecting something in return, right? Okay, so I'm not sure, like some sponsor, they might want publicity, but in our case, actually pretty less, because like they are all well known enough as a global company. But what I think like the concern is more on like how much technical impact they can generate, especially for younger generation, for example, like undergraduate. So how much impact they can actually generate in creating academic value, for example. So, and if this, you can do it in a much bigger scale, not just in your university, but somehow in North America and so on. And I think like we can actually discuss how to actually connect you with more sponsors later on and externally and so on. But currently what we are looking for is like, for example, in Asia, I'm currently in Asia, so I'm actually leading most of the activities in Asia, and our one of our committee, Luca, Professor Luca, in Italy, so he's actually running a lot of projects and also activities in Europe. But what missing is in America, that we have one very active committee member, Amy, also is also working on very similar thing, and Amy has trying to look how to say actively on how to actually bring you guys together. So, and for Canada particularly, I know like previously I worked with Sarah, that later on maybe I can pass the contact with you. So these people are the people that try to link up and establish the network in North America region, right? So I think if you get in touch with all these people, they are able to connect you with sponsors and opportunity. For example, like in RoboCup, we have a lot of funding opportunities, and also exchange that come with financial support opportunity. Hopefully like it will still continue, because like for the past few years, based on the record, it's available some funding that you can apply and so on. So these are the things that I really hope that our community, for example, like in we can actually make our at-home education activities very visible and very appealing, and you try to connect with the network so that eventually you can get enough support to actually run your activities. So that is what my message to you. So hopefully like after this, like I can share the contact with you, and you guys can talk to each other, especially those team in North America. I think it's very important for you, because like I can see you're very active in your university itself, so you have a lot of commitment and also motivation over there. But don't stop there. I would like you to actually bring up the community around you, right, in Canada, and also try to connect with Mexico people, try to connect with people in US and so on. And they are actually very active, and I can tell you like the team in Mexico, they are very experienced. I mean, like they have joined at home for many years. If you know the history, you know them. And then for Amy, is very how to say, is a veteran in RoboCup. So I think like but the thing is, in North America is like all scattered around. So I hope like you all can gather around, and you can see a good example is in Europe. So they have Europe activities for RoboCup for many years, and next year, so this year is supposed to be in Portugal, and next year we are going to host our event in Portugal for Europe Championship. So hopefully like eventually we can have some event in North America as well, right, for RoboCup, because we know our friend in first, so they are doing a good job, I guess, but they are like targeting something different from us. So in RoboCup we target something different. So we hope that this successful model can be how to say, can be built up in North America. So that's why I see like you guys are very, how to say, eager and also very active in this development. So hopefully like I can actually link you up with more resources and also people around you. So that is the idea. But the how to say, the favor that I would like to ask is like you guys might need to be the champion to actually come forward to show people what you have done and how things can be done in your region. For example, like you can actively try to promote all these activities around your region, because I'm sure the first thing that you would like to do is to bring up the community among you, because you might want more local activities, okay? Because you're joining RoboCup at home. I know you want to join at home next year, and you better start preparing, because it's really not easy. Okay, I join at home as well, so I know the whole process is not easy. So a lot of things that you need to consider, especially for student-driven teams. So you can refer to one of the student team, which is they are very excellent in OPL. So they are student-driven, and they teams from Europe. I can't remember what is the name. Okay, so but anyway, so they are good, and you can refer to. But the message that I want to tell you is, if you work alone in your university, I think the growth will be very slow. I mean, like not in scale. So in order to scale your growth, if let's say you can work with your community and bigger community, for example, the North American community and so on, you can get more resources in terms of funding, in terms of technical support, and so on. So that is the message that I would like to pass to you in this session. But of course, I think like I have like say more than Q&A. So let's go back to the question. So just now you talked about the engineering design process and also how you manage all those things and so on. I would like to know that how actually, for example, like I think like you have restarted your teams in 2019, right? So how this framework actually how to say, how you set up this thing? Are you formulating all this thing by your own, I mean like in student level, or how the new, for example, like you have new member this year come in, okay, they're their first semester, first year and so on, so how you actually educate them or expose them to this kind of working culture apart from the technical development? So how you manage and to tell the new team, and also how you want to retain this system in a cycle, because like as you said in 2017 the senior all graduated and then you disband because you have nobody inside there to retain all the know-how. So how as a team that in university, in order for long-term sustainability development, how you actually work like senior and junior, how you actually make the thing work in a cycle?
Yeah, so that's actually, as you mentioned, that's something that we're experiencing now with our sort of rapid turnover with people graduating. And what we've noticed to be tremendously helpful is documentation.
Okay.
I know we were talking about this early as well, but having that documentation. So right now what we are really encouraging our leads to do is write guidebooks for the successive leads. So doing that succession planning in advance is extremely valuable for us, we have found, since sometimes things happen and sometimes people may graduate earlier than they expected or so on and so forth. And so having that is extremely, very, very valuable to our sustainability. And also just in terms of not just leadership only, but just in terms of any sort of position, we make sure that everything is very well documented. So every position on our team has a description. Every position has a name and a description, and it is very clear when someone is signing up for the team and they get a position, it's very clear what that position entails. So they have all the roles and responsibilities. And in terms of the design cycle, so our university has a first-year engineering course that does an introduction to the design cycle. So since a lot of the students do choose to join our team in their first year, they are somewhat familiar, but not all students are. And so for those who are maybe transfer students or who did not do their first year in engineering, then we do teach them. So with our leads, with our kind of sort of the ladder structure we do quite a bit of mentorship and a lot of teaching that goes into that.
So I guess I think it's a very nice attractive point that you can say to your new members or during your recruitment that joining your team not just learn about technical development, you learn about project management, and all these things are very, how to say, important in later on when you're looking for jobs and you want to become the engineers, because like engineers, like you have technician below that take care of the technical and you need to do the project management and so on, and these are the experience that is very important. And also I'm not sure, like, okay, in the list I'm not sure like any of you belongs to the faculty member, but I got one message or one sharing knowledge, I mean like experience that you can share with the faculty member in your team is like, if you can actually link all these activities that you are doing with your academic and research, it will be more sustainable. And that is a very important point. For example, like I have many teams that talk to me that they said they don't have so much funding for student activities, right? And the student feel like if they do this thing for student activities, it's not really beneficial for their studies and nothing to do with their research and so on. So if that happen, then you will have a conflict in terms of time management. You do this based purely on your interest, and maybe you earn something, the value, but you don't know the value until like maybe you step out from your university. So, but it not necessarily supposed to be the way. So a more wise way is like if the faculty member can think of how to make the activities within your group that part of the academic. So how to relate. For example, I'm not sure, like, but I'm pretty sure that in engineering we got project management related subject, and you have final year project, for example, like all of you have final projects before you graduate and so on. So how you want to link your effort and your activities in this activity, in this process to those kind of requirement in your academic, and then it will be more appealing. For example, I'm a student that I would like to find ideas about my final projects, right? And then I can see a lot of previous case that student work in this your organization, they have resources in terms of lab facilities, knowledge, senior mentorships, and all these things to help them to achieve something in the competition. At the same time, that part, whatever that they have done in that, is also their final project. And that makes things very appealing, very attractive, and also it will let them see that this thing got more value to them personally, because like everyone enter the college, there are one of the very important objective is to graduate, right? So that is a very obvious objective they want to achieve. So if you can link that to your academic, I think that will be very important, very useful, and for sustainability. And another one is like for at-home education. So why, particularly like so many league in RoboCup and also so many robotics competition out there, but I choose at home and this kind of development is because I can see a lot of research value and potential in this development. So whatever that you do, like how to learn machine learning, how to do AI stuff, and all these things are very, how to say, state of the art. So always like we look state of the art and we develop and all those things. Although in undergraduate you might still in the stage that you're learning, but you're actually learning at the very top of the technology, because you always use the latest technology for your development and so on. Okay, so the research value is always there. So if let's say you have any faculty member, so just to share with you, a lot of top team in at home, they actually get a lot of funding to fund the team is because they are developing something for research. Okay, so that's very important, and that is also very amazing, is because like at home itself is actually try to promote research in terms of this AI and service robot development. So if you can actually have faculty member that interested, and you can show them like in what the requirement in at-home education, the technical side, the research value over there, then they will say like, okay, yes, I can get like research funding to develop this technique, and you can use this technique in the competition to actually use the international benchmark to show that your research or whatever development is up to a certain standard in research community. And that will actually link these two together, and you will get a lot of funding, you know, like research funding in terms of that. And then I think that will be very useful. So I would like to share with you this experience, is because I observed many top team in at home or in RoboCup, they actually linking very well their development in competition and also their development in research. So that is also one of the way that you can consider to talk to faculty member that, for example, they work on computer science, they work on AI, they work on facial recognition and so on, especially those faculty members that work with companies. For example, they work with companies for this image processing technique, and you can use this technique to develop some application in competition to showcase the effectiveness, or better still, you get a gold medal or things like that. Then that is actually one of the benchmark and recognitions that you can bring to the project team, and that is one of the delivery that they will be proud to have. And on top of that, I mean, like in return of that, yeah, you can have all the support in terms of financial. So I guess that is very important, that if you can connect, then yeah, that will be very helpful for your team. That's what I would like to share with you. Okay, right. So I think like I almost come to the end. It's almost 2 hours. We have about 10 minutes to go. So the last question is like, as a student, what do you think? Maybe I'm not sure. Like maybe you just joined, or you have joined a long time, and also you have some experience in this, and you have gone through. But I'm sure like you have gone through a lot in this team. So as a student, I would like to listen to your opinion, what you have achieved or what you have gained. Okay, before, so you try to compare yourself before joining at home education activities or whatever activities in your team, and after you have joined at home education activities. For example, like you have gone through the online challenge, you have participated in the online classroom and so on. So if you compare these two stages, can you share with us like what you have gained throughout this process? Because I would like you to tell the people that would like to join these activities what they can actually expect in order to join these activities. Right? So I would like to hear from you. Right. So come.
I
start
think.
from. Yeah.
I think I can like add some things from that. Well, so for like the machine learning AI software team, this was like our first year that we gathered. We formed this sub team, and we actually started working on these algorithms. So I believe, so we were a small team from the beginning, and the whole emphasis was to produce as much technical work as possible in order to be able not to win something, but just participate in the competition. And this really pushed us to the limit of getting new knowledge and getting real applicable experience on the field of machine learning, which everyone knows that it's like a very hot topic right now. So I believe, especially after like the quarantine, and the captains really pushed us on continuing to work on this project and still submit our work for the competition. I think all of the members gained great value out of participating for the RoboCup at Home Education Challenge, and this is one of the reasons why right now we're focusing so much on documenting on work and on the administration work, because we value this experience so much that next year we want newer members and newer participants from first years or second years that are gonna be joining the team to have also the opportunity to participate on this education challenge.
Thank you. Any more? Just personal opinion is fine. And also, yeah, it doesn't matter really like just technical gain, any gain, like experience, like you gain actually a lot of fun. You have like better social cycle, you know more people and all these things. Just as a point of view from a university or undergraduate students, any good points that you think is good for you to join these activities? Yeah, feel free to share with us. Any more comments from other members?
Maybe I could share a little bit.
Oh yes, I'm waiting for you to speak all the time.
Oh yeah.
Right.
Well, I'm one of the junior, more younger, fresh.
Okay. Yes.
I don't know how to put it, but
yeah, feel
junior
free.
members
Feel free
of the
to,
team, right? So maybe I could come at it a little bit more from like a first year university student. I think last year when I first joined, UBC, and was looking for a design team, this was really a new experience for me in terms of, the technical things aside, also that kind of whole project management that we got into earlier. Because I think I was, as a student, personally, I was very involved in clubs and whatnot in high school. But coming into university, you really get to blend technical knowledge, the specific technical knowledge that you would gain that is also useful later on in the industry, with that kind of community, that club, to really put that together. Overall, I would say I'm beyond thankful to all the leads who are here for, I think last year, they mentioned just last year, they implemented that mentorship program, which really helped give me a view of overall what kind of work that, engineers are doing. And I like this one quote that I read one time from Freeman Dyson. He's a mathematician and talks about birds and frogs, right? And a critique is smiling because she helped me with application for actually one of my second year course. So that's the other side, right? The community, right? So the quote is about birds and frogs, to get into detail are there in the mud. They see the flowers nearby, whereas the birds, they get the broad visions and the overall general concept, right? And I think robotics is one of those fields where you really need that kind of vision to see where the field is moving and how everything comes together. I think I thought I had a concept, but I really didn't understand how everything was going to work together like that. And it was really helpful in terms of just people-wise to be able to interact with people from mechanical engineering, electrical engineering, computer science, and all that. Before I had done even programming competitions and personal projects, but it really wasn't the scope that was needed to encompass all of this. I think this also applies not only to our team, but also to the RoboCup at home education and just the regular competition, because it really gives us something we can work together, because it provides tremendous value in terms of the projects that we're actually working on. And it also helps bring together many teams from across the world to work together with some guideline in terms of competition. And yeah, so as for my first year, I think it was a wonderful experience to be able to come into an environment such as this. And I can say it's much better than some of the other, well, I don't want to say anything, but I've also joined other things in which things are less organized and lots of meetings, lots of bureaucracy, nothing ended up really making any impact, right? So yeah, I think maybe that can help some of the more newer members, especially first years when you really don't have a lot of technical knowledge at all. This really helped me learn a lot. Yeah.
Thanks for kind word. Very nice. Very good for our promotion. Well, any words from two leaders over here? Yeah, our female representative.
Hi,
Yeah,
okay,
you need to say something about being women in the involvement, right? Yeah.
Oh, don't worry, I'm about to say that.
yeah. I think that's an important point that you should point out. Yeah.
Yeah, so I guess I could shed a little bit more light on my story of how I kind of ended up on the team. So in first year, I'd applied to a couple of teams. I didn't get on one. I did get on this one, and I was like, okay, I'm really excited because robotics, all that. And they had kind of pushed the RoboCup project from the beginning, so I knew it was a thing. But initially, they had a mentorship program that they went through. It's just that at that time, I joined in 2017. I was in first year, so that's what I was saying when the communication wasn't very strong. So we'd show up to these meetings, and they would just be like, oh, just follow the instructions online, just do stuff, you know? And I was like, I'm not really sure this is kind of the environment I expected myself to be in. I expected a little bit more mentorship, because I know as a first year, it can be a little daunting to take on these things when you have no coding experience or, you know, computer, like anything experience in engineering, right? I was coming from like very limited experience, so I was pretty nervous about that. But then one of the captain at the time, he kind of got me involved in one of the projects, and then as he graduated, then he asked me to kind of take over. And I remember when I first kind of got into the administration role, all the other leads that I had with me were boys, so I was kind of the only girl in the mix, and I was just like, okay, well, I didn't realize it for about half a year, to be honest, because, you know, it was such a great group of people. But at some point I did realize, and I was like, oh, hey, maybe we need more girls on the team. And luckily, my co-captain happened to be a girl. She's amazing. It had, you know, yeah, she was just great. You know, I would have chosen her even if she wasn't a girl, but, you know, love you, Nikki. So yeah, it's been a really, really wonderful experience. And the competition, the nice thing about RoboCup is that it's not just a project for us university students. I think it's a bit of a vision and a dream for us, because, like, if you've seen a movie like what's it called, Big Hero 6, it's a Disney movie, And yes, they don't frame robotics in the most, the most realistic light, but it kind of gives you the interest to look into that kind of thing. And how I always saw it is the main character from Big Hero 6 Baymax is kind of like what RoboCup at Home organization is kind of tailoring their robot towards. I know it's a little silly, but I think it's a great thought. And that's kind of how we like to do a promotion. Like, this is kind of the thing that we're working towards. We're trying to come up with something that, on top of just participating in an organization and kind of participating in state-of-the-art research, is also to build something that at the end of the day is affordable and can help lots of people all over the world. So kind of getting involved in that kind of atmosphere, I think, has been really inspirational. I haven't really felt any discrimination or anything as a girl, honestly. Like, the team is just so amazing. So there's not really much to say there, except, I just wish there were more girls in robotics, because it's definitely a really friendly and interesting field. And I think people tend to think there's a lot more discrimination than there actually is, at least in my experience. And I think that when people realize how amazing it is, there's going to be swarms of people in robotics. Yeah.
Yeah, but as a fact that I actually have many students who are good in coding in our teams, and they are female. Just to share with you one of my experience. Yeah. So there's no difference actually among genders in our development. There's really no different, and actually it's really come to how that person able to pick up, and somehow I actually realized that female actually can pick up very nice skill in our team development as well. Right, well, your turn, co-captain.
Thank you. I think Kritika put that absolutely eloquently, and I completely agree. I don't have much to add on to, other than I think representation is so immensely valuable, and I recently became a co-captain about 7-8 months ago, so kind of the start of our RoboCup project, and I'm so honored to be a part of the process and to supervise our amazing team in building the robot and getting that funding, doing all these amazing things and reaching those incredible milestones. So for me personally, it was an absolutely incredible experience filled with a lot of growth, as it was my first big project that I was co-captaining. So it was an incredible success. And also adding, like, on the front of representation, I think it's so valuable, and especially as again, because the captains on the team are women, I think it's really valuable that we're showing other, especially first year students who are female and other women on the team, that women in STEM are valuable, and that women in STEM can have high power positions. Even though this is just a student team, we do our best to mimic a sort of work environment that you would see in the actual professional setting. So yeah, that's why I think representation is so important. Is I've had multiple newer students come up to me and say, "Oh, well, I never really thought you could do this, but yes, you in fact can." And I really thank robotics for that, for giving me that sort of opportunity to do what I can to empower other women.
Yeah, cool. I mean, like, I really look forward, like, eventually you can build a BMX in your team. Right, so it's a very fun, and I think that this session I enjoy a lot, like, especially talking to you guys is make me feel very young. Right, so as the ending, so I would like to, like, again, I need to do some promotional. So let me put up my slides. Okay, so before all of you go, right, just bear with me for another, like, 2 minutes. Okay, so for a lot of you that looking at this video or join this session, so we have quite a number of guests today. So for the rest of you that watch this thing later on in our YouTube channel, so if you would like to know more about our activities, and if you would like to join us, and feel free to look at this field link, right? So we have our website that contains all our information. If you want to, like, communicate with us, feel free to like our Facebook page and also join our Facebook group so that you can interact with us. You can actually message me directly from there. And also, if you are interested to know, like, what kind of open software that we actually open up in our classroom, so the next two link, our GitHub contains all our open code, like if you want to know how to do face recognition and so on. And for deep learning package, we are going to up soon, so stay tuned. And for online classroom, we are actually planning the next series. But I also look forward like community, because now just want to share with you like our community in India. So they have organized their ever since they joined our activities in 2017, then they joined again in 2018 or 19. Then they actually organized their own challenge in India, okay, early this year. And also they organize, currently they are actually running a 10 class online tutorial for our activities. So it's open and you can join, right? So I actually look forward like community in UBS, you guys, to see if, let's say, eventually later on, you can use all the resources that are available from us, and also all the content that generate among your team. If, let's say, you are organizing activities among your community, for example, like for your new members, or you are actually planning to do some, for example, workshop for your communities, or you want to do some competition for a community, feel free to share with us, and we would like to see whatever mean and whatever resources we have to support your activities. All right, so just to share with you one of the case that we have community in Europe that they have running a lot of activities, and this year we have community in India, they have currently running the online tutorial. All right, so feel free to look at it. For the rest of you, feel free to look at all the materials and feel free to use the materials for your community. Yes, and eventually, like if you have very special case that you need to contact us, that is the email, and you can reach directly into our mailbox. Okay, all right, then the last sorry, I need to switch back. Okay, the last things that I need to say is this one. Okay, so last week we have the teams from Macau, and today we have team from Canada. So next week we have teams from Malaysia and China, and continue until September for this special online challenge 2020 invited lecture series. So stay tuned with us, and we will put our registration link over there on our website, so feel free to sign up and join our activities. All right, so with that, I would like to say thanks to all of you, especially our guests, our very special guest today that share with us very interesting experience, I would say, and also very surprise content about how they actually, undergraduate students actually do a very professional engineering process or engineering project management stuff. So it's a very nice content. So all this content is currently recording, so we will actually put up on our website eventually and share in our social media. All right, so thanks a lot, thanks everyone, and I appreciate your work, and I look forward for more development and also more activity together with you. All right, okay, thanks a lot.
Jeffrey.
Yeah, thanks. I would like to say bye, and I'm going to off this, but please don't offline first. Okay, so I have some contact that I would like to tell you after the recording. Okay, so I will just stop the recording first. Right, okay, so see you, bye.